In the earlier class, we have discussed about dispersion of light through a prism. Because when the incident light has two or more wavelengths that are present in it and is able to travel through a prism, as a different refractive indices that are exhibited by the prism towards the different wavelengths that are present in the incident light. So the light gets dispersed according to the wavelengths, the way how the people gets dispersed after assembly according to their class or section. Similarly, the light gets dispersed according to the wavelengths present in it when it is allowed to travel through the prism. That's what we have learned in the earlier class, dispersion of light through a prism. And also the concept of spectra, which is a group of colors or the group of wavelengths. Now, we are going to discuss an interesting point here. Dispersion of light in atmosphere. How do the light gets dispersed in atmosphere? And that causes the formation of rainbow in the nature. This is what our concept now. This is an interesting and easy concept. But here the point it is, whenever the rainbow is observed in the nature, the first thing that what you need to accept it is there is a dispersion of sunlight that is going to happen in atmosphere. If not dispersing, we can't find the rainbow. So as we are finding the rainbow in the nature, in air, which is a group of different colors, so certainly there is a dispersion happening. That's first point we need to accept. Okay, done. Dispersion is happening. Then who is dispersing is the next question. So what will be present in air, in atmosphere? There are many more gases. All those gaseous molecules. Of course, light usually travels through atmosphere at a speed 3 into 10 power 8 meters per second. But apart from these gaseous molecules, something is going to disperse the light. Then what is going to disperse the light? Who is that? So to understand this, when do we observe this rain? When do we observe? Usually just after the rain or just after a drizzling even. Whenever there is a sunlight, whenever there is a hot sun comes immediately, then we are going to find the rain. Am I right? So when there is presence of sun during the time of rain, once the rain disappears and immediately sun has come onto the stage, then we are going to find the presence of rainbow in the nature. So how that is possible is all because of your water droplets that are present in the atmosphere are responsible for dispersion of sunlight. So who is going to disperse the light in the atmosphere? Water drops. How do the water drops are going to disperse the light, and what is going to happen basically, that we are going to discuss here, the basic phenomenon dispersion in the atmosphere. You can see here the sunlight is going to enter into the water droplet. Many of the light rays are traveling through the atmosphere. There are many more droplets that are existing in the atmosphere. I am talking about a particular droplet, and I am supposing the sunlight is going to enter. Most of the light rays are going to enter. I am talking about a particular incident light ray that is going to strike the water droplet. Then this water droplet, of course you have learned the refractive index of water is 4/3. You have learned. But my white light or my sunlight has a different wavelengths that are present in it. Then my water droplet acts as a prism for the incident light, because the incident light has a different wavelengths that are present in it, from violet to red. So my water material medium will show different refractive indices to different wavelengths. So due to that, what will happen? Dispersion of light will take place. The water droplet in atmosphere will act like a prism. Then how do the dispersion takes place? You see, violet goes for more deviation, red goes for lesser deviation. This is red color and this is violet color. So whenever these light rays entered from air to water, as a water droplet, this is water droplet. As water droplet acts like a prism, that's the dispersion of light takes place. Now, at this interface, the light rays are going to travel from water to air, atmosphere, water to air. Water is a denser medium, air is a rarer medium, you know comparatively. Then in that situation, there is a possibility for TIR, total internal reflection. What we have discussed in the earlier class, when the light is traveling from denser medium to rarer medium, there is a possibility for total internal reflection. I don't say that whatever the light traveling from denser to rarer will go for TIR. I don't say that. I do say that the light rays which are traveling from denser to rarer and falling at an angle of incidence more than critical angle, then the light rays gets reflected. So, few of the light rays which are traveling from denser to rarer may go for total internal reflection here. Then in that process, here in this way, violet goes for more deviation anyway, red light goes for less deviation. So in this way, TIR can take place with few light rays. Again, they are going to travel from water to air. Again, there is a possibility for TIR. There is a possibility for refraction. For both there are possibilities. But what we are explaining the concept of observation of rainbow due to dispersion of light by the water droplet. So here I am explaining the concept of refraction, where the light rays bends away from the normal. So it is. This is violet and this is red. And when the observer is here, he will be able to get those light rays. Here is the sun. This is what the concept. That's the reason why we observe the rainbow when the sun is behind us and in front of us, we can see the rainbow. If I turn like this facing the sun, I will not be able to find the rainbow. While finding the rainbow, certainly I should not face the sun. Sun should be behind the observer. Then the sunlight which is coming from behind the observer gets dispersed in atmosphere by the water droplets. Then such totally internal reflected light will travel through water droplet and will emerge into air and will be received by me. So the observer will have sun behind him while finding the rainbow in the sky. This is how usually rainbow will be observed by the person. But here the point that what we need to understand it is when the different lights that are coming from the water droplet, violet to red, are not all received by the observer, because violet is coming in one direction, red light is coming in one direction, blue color will come in another direction. If the observer is going to find red color, then he will not be able to get the violet color. If the observer is going to get the violet color, then he will not be able to identify the red color. Any one color he will be able to identify in his particular placement, because different colors are coming along with the different parts. Then again question, sir, then how do I find the different colors during rainbow? I am able to find all the spectra of colors during rainbow. How that is possible? Again that will be question. I repeat the question. When the observer is at a particular place, of course, in the direction of receiving red color light, then the same person will not be able to get violet color coming from the same water droplet, because that is coming in another direction where observer is going to receive red color. So the question is, then how do I can find different colors in the rainbow? That I am going to explain. You see, there is not a unique water drop in the atmosphere. There are many more water droplets. So let me take, just for an example, 2 water drops that are present in the atmosphere. This is first water drop. Here is the sunlight. Here is a dispersion. Hope you are following. This is violet and this is red. Now here total internal reflection takes place. Again refraction takes place. So ultimately this is violet and this is red. But there is another water droplet through which the light is getting dispersed, and then the total internal reflection takes place, and then refracting out, and the observer is here. Then the observer is able to get the red color from one water droplet and the violet color from the another droplet. So this is how the observer will be able to get the different colors that are coming from the different water droplets. Just example with the two droplets. As there is a complex phenomenon to explain for every drop in the atmosphere diagrammatically, just I have explained with the two water droplets. So when I am going to find a rainbow with 3 or 4 colors in the nature, in the atmosphere, then all those colors are not coming from single water drop. That is my intention to tell you. That is my intention to tell you. My intention is to tell you that when I am finding a rainbow with a combination of 3 or 4 or 7 colors, sometimes some colors are not visible because of lack of energy levels within the light. So whenever I am finding some different colors in the rainbow, my point is to tell you that all the colors that you are receiving are not from a unique droplet. You are in a particular position to receive the red color light from one particular drop, so that the other colors, the blue color or green color, is coming in the same direction to your position, so that the green color from another drop will not come. From the third drop, some violet color may come. From fourth drop, some yellow color may come. Like that, different colors of light are coming from different water droplets to your particular position. Because when our position is fixed, you will not be able to get all the colors that are coming from unique droplet. So when our position is fixed, you will be able to get different colors of light from different water droplets. So we have discussed about the concept of dispersion of light in the atmosphere and the formation of rain. So ultimately what we are going to conclude is, when the sunlight is traveling through the water droplets that are present in the atmosphere, it disperses first, and then total internal reflection takes place, and then refracts from the water droplet into it. So these are the 3 steps that are going to happen during the formation of rainbow in the sky: dispersion of light, reflection, that is total internal reflection, and refraction of light. So these are the steps of formation of rainbow in the sky, whatever we have discussed till now. So apart from this analysis, I am going to attach a video presentation to this, so to understand more clearly the formation of rainbow in the sky. But what you need to understand, once again I am telling you, remember, when the sunlight is going to disperse through water droplets and total internal reflection takes place and then refracts, the point what you are going to observe here it is, the sun is behind the observer and the sunlight is traveling through water droplets and then disperses, reflects and then refracts, reaching the observer. So the observer will have sun behind him during the observation of rainbow in front of him. This is what the clarity you should get here itself. Sometimes we may find some 2 or more, 2 rainbows at least even in the sky sometimes, which we call the second one as secondary rainbow. So there is a concept of primary rainbow and secondary rainbow because of presence of more quantity of water vapor molecules that are in the atmosphere. So on explaining all this, even a video presentation will be attached to you. You go through that. So this is all the concept of refraction through a prism, what we have discussed in the earlier class, and dispersion of light through a prism, and then dispersion in the atmosphere and formation of rainbow. This is all the entire concept of what we have completed till now. So the next topic that we are going to enter it is refraction of light through spherical surfaces. Of course, as per our textbook language, refraction through lenses is the next topic that we are going to discuss in the coming classes. This is all about refraction of light through prism, dispersion of light through prism, dispersion of light in the atmosphere, and the formation of rainbow concept. That's what we have in the lesson, which is human eye and colorful bulb. But connecting with the regular concepts, we have connected with this earlier itself. But every point in the textbook will be covered, of course. So this is all what you need to refer even the textbook lesson also. Thank you.
See, in the picture, you are going to see the different visual effects that are caused due to the sunlight, like blue color of the sky, even the clouds appearing white, the red hue around the sun, even the formation of rainbow in the atmosphere. So usually we find the rainbow when it just rains, because whenever it's raining, the water molecules that are present in the atmosphere, even the water droplets. So here, when the sunlight is going to travel through the water droplets that are present in atmosphere, then the light is going to disperse through the water droplets. So that due to the dispersion and then total internal reflection, there will be formation of rainbow in the sky. But the thing I told you even in the class, the sun is behind the observer. Now, once you try to look at the diagrammatic representation, the light that is going to enter into the water droplet, once it just has entered into the water droplet, it gets dispersed, showing as refraction, but it is a dispersion what you need to correct from the figure. The first one is dispersion, it's not at all about refraction. So when the light gets dispersed, the sunlight gets dispersed from violet to red as shown in the picture. I repeat, the first step is not refraction, it is a dispersion of light. So the dispersed light is going to fall on the second curved surface of the water droplet, so that the angle of incidence is 48 degrees more than critical angle. So in the second step, there is total internal reflection. And in the third step, the light refracts out from water to air. Now you can see the uppermost light is violet and the bottommost one is red. So violet to red, the light gets dispersed and then coming out of the water droplet. Of course, the angle of deviation for violet is 40 and that of red is 42. So that means the angle between violet to red remain as 2 degrees itself. Now you can see there is not only one droplet that is in the atmosphere, there can be many more droplets. So that I told you even in the earlier class, if the observer is going to get the violet from one droplet, from the other droplet the observer is going to get the red color. I told you, the observer do not get all the colors from a particular droplet. While observing the rainbow, the different colors are going to reach the observer, which are coming from different water droplets that are present. Of course, the first step is not refraction, it is a dispersion. The second step reflection, and the third step is all about refraction. I repeat, dispersion, reflection, I mean total internal reflection, and then refraction. Now you are going to see the diagrammatic representation to explain the formation of secondary rainbow, where the light goes for multiple reflections within the water droplet. After getting dispersed, it goes for multiple reflections within the water droplet, and there is a possibility for the formation of two rainbows in the sky, whereas the intense one is primary rainbow and the other dull one will be taken as a secondary rainbow. So this is how we can explain the formation of rainbow due to